more at errors in calculations. This is an experiment where we've got to find the power of the bulb using this circuit. So we've got an ammeter to read current, we've got a voltmeter to read voltage across the bulb. We're going to work towards using power equals current times voltage to figure out what the power is, but we're getting our readings from these analog scales, so obviously there are going to be some uncertainties in those scales. So here's our ammeter reading and here's our voltmeter reading. So the first thing that you want to do in order to find the power of the bulb and its uncertainty in both absolute and percentage forms is figure out from your meters what your values of V and I are. So if we look at V first, you should find that V comes out as being 8.5. So each scale division is 0.5 of a volt. So if you count that up to here, you'll find that V is 8.5. Current next. Current has a slightly smaller scale. Should find that that is 1.6 because it's 0.2 per division. So therefore half a scale division will be 0.1 in a moment. So 1.6. There are reading errors in both of those values because they are taken from an analog scale. For an analog scale, it's plus or minus half a scale division. So for V, the scales are 0.5 per scale division, so it's 0.25. So this is 8.5 plus or minus 0.25 volts. And as we just mentioned a moment ago, for current, it's 0.2 per scale division, so half a scale division is 0.1. So we've taken into account the errors for both of these. We're now looking to calculate what power is. We can calculate power out first of all using P equals IV. We can calculate what our final value will be. So that's using these values, of course, not using the errors. So it's 1.6 multiplied by 8.5 should give 13.6 watts. We've now got to calculate what the error within that 13.6 watts is. In order to do that, we need to calculate the percentage error for both of the values V and I. Percentage error is of course just a basic percentage calculation. It's the error divided by the value multiplied by 100. So if we do that for V, first of all, the percentage error for V will be this value, this error, divided by the total value. So it's 0.25 divided by 8.5 multiplied by 100 gives you a value of 2.94%. And for I, the percentage error is 0.1. So percentage error we should have there. Percentage error is 0.1 divided by 1.6 multiplied by 100 gives 6.25%. So we've got two percentages there. What I've been teaching you to do is to select the percentage which is larger and use that in your final answer. So it's the percentage error in I that we're looking at this time. We're going to completely ignore this 2.94% and just use this 6.25% in our final answer. So that will be P is equal to this value of 13.6 plus or minus 6.25%. So that's you expressed your answer in percentage form, which is this first wee section here. We now need to express it in absolute form, which is basically taking that percentage and converting it into a value, you know, like we've got here. So you're taking 6.25% of 13.6, which should come out at around about 0.85. But remember, we want the error in the same format as the value, so your next step is to round that 0.85 to 0.9. So it's 13.6 plus or minus 0.9, and then put your units in. So that's you now got it in absolute form as well. So it's the same technique for any sort of experiment or set of results where you've just got a couple of values, you've got to calculate what the final value is, you've got to take into account the error in both of these, so you find out what the percentage error is first, use the largest percentage error in your final answer, and make sure that you give your uncertainty in the same format as your final value.